All right, it's time for everybody's favorite word problems, right? They are not that bad, I promise. Okay, so we're going to walk through it. We're going to look at two different types today, and that's it. All right, so let's just jump right in. Take a look at number one. It says, find the value of two numbers if their sum is 13 and their difference is 1. Now, I know you might already be thinking, you might even have the answer in your head already. You're not always going to be able to do it in your head. So let's walk through how to do this algebraically, and then we can apply it and see how this works. So find the value of two numbers. So my answer is going to be two numbers. I don't know what the first number is. For me to do is to literally say, let x equal, that's an x. It's not a very good x. There we go. Let x equal my first number. And I'm also going to say, let y equal my second number. Okay, it's just that easy. I'm going to use a different variable to represent each one. One number is x, the other's number is y. I don't know what they are. If you have two variables, in order to solve for those two variables, you're going to have two equations. Okay, same thing holds true if you had three variables. You would need three equations, four variables, four equations. So we're going to have two variables, so we're going to need to come up with two equations. Luckily, they give me enough information to do that. Here's one right here. Their sum is 13. What operation is sum? Hopefully you're thinking addition. So that literally says, take your two numbers and add them together, and you're gonna get 13. So there's one of my equations, x plus y equals 13, the sum of the two numbers, okay? And then I have over here, their difference is 1. So what operation was difference? Do you remember? Subtraction. So now I want to take my two numbers and I want to subtract them. And my answer is going to be 1. Okay, so there are my two equations. And now you guys have all those different ways to solve a system. You could solve by graphing, substitution, or elimination. Okay, we practiced in the last session which makes the most sense. Okay, so in this case, elimination makes the most sense. You already have a positive y and a negative y. It's ready to cancel out. Okay, so once I see, and you could solve it any way you want, but you might as well do that, right? That's the easiest one. So the y's are going to cancel. X plus x is 2x. And 13 plus 1 would get me 14. Divide by 2, divide by 2. It looks like x is going to be 7. So now I know what my first number is. It's 7. First number is 7. So now go back to one of my original equations that I wrote. X plus y equals 13. We'll just use that one. Now that I know that x is 7, I can go ahead and solve for y. So you probably already see that y is going to be 6. Okay, so I know we don't have a ton of room. Normally I would ask you to write me out a sentence telling me the answer. So if you can fit it in, that's great. If you can't, I mean, I get it. So maybe I just say the numbers are 6 and 7. Okay, so I actually want to jump down to number 4 because that's another problem that's very similar to this one. So let's just jump down to 4 and do that one together. Oh, for Pete's sake. There we go. Kind of. Okay. So this one just so happens to be awfully similar. Find the value of two numbers if their sum is 15 and their difference is 1. So again, I'm going to say, let x equal my first number. I don't know what it is. I don't know what my second number is, so I'm going to call it y. Okay, so now I have a variable for each one. And let's read. Their sum is 15. So one of my equations will be x plus y equals 15. And then my second equation comes from the next part. Their difference is 1. So if I subtract my two numbers, I'm going to get 1. Okay, this is another one. It's ready for elimination. So let's just add these two together. The y's are gone. 2x equals 16. This time I get 8 for x. So 8 is my first number, and then my second number would have to be 8 plus y equals 15. Subtract 8 from both sides. So that's going to get me 7. Okay, so the numbers are 7 and 8. Okay, hopefully that makes sense. And you can check it very quickly. If I add 7 and 8 together, yep, I get 15. If I subtract 8 and 7, yep, I get 1. So I know that I've got the right set of numbers. Okay, so now let's go ahead and take a look at what at first appears to be a totally different problem, but they actually aren't all that different. Okay, so let's look at number 2. The school that Callie goes to is selling tickets to a play. On the first day of ticket sales, the school sold $100. The school took in $120 on the second day by selling 6 adult tickets and 9 student tickets. Find the price of an adult ticket and the price of a student ticket. I know this probably sounds super confusing to you, and you're like, I have no idea how to do this. That's what I'm here for. Don't worry, I will help you. So I want to point out a couple of things. There's 2 things happening. There's the first day. That's going to be one of our equations. And then you have the second day. That's going to be our second equation. All right. I used fantastical colors on accident, but on purpose. Okay, so any Hoosers, we need to go ahead and I bet Caden and Elizabeth are laughing at me. All right, anyway, so let's go back and read. What are we trying to find? We're trying to find the price of an adult ticket and the price of a student ticket. So there's the 2 things that I don't know. So I am going to, again, assign a variable to each one of those because that's what I don't know. So let's just say let x equal, and it doesn't matter which one, I'll say price of an adult ticket. So then y would be the price of a student ticket. All right, now that I have my variables set up, I'm going to go and I'm going to look at my yellow sentence and I'm going to look at my green sentence and I'm going to write an equation for each one of them. Once I have the equations written, you can kind of forget that it's a word problem. You're just going to solve and then give me my answer. Okay, so let's look at the yellow sentence. On the first day of ticket sales, the school sold 6 adult tickets and 7 student tickets for a total of $100. Okay, I sold, the people at the school sold 6 adult tickets. Okay, so think about that. I don't know how much the adult tickets were, but I sold 6 of them. So wouldn't that look like, let's see if I can actually use yellow. Wouldn't that look like 6 times X, however much whatever the price of the adult ticket cost, right? I don't know. Maybe it's $10, maybe it's $20. I have no idea, but I sold 6 of them. So 6 times whatever that price was gets me all the money that I collected from the adults that day. Then I also collected money from the students. In the yellow sentence, it says 7 student tickets were sold. So I sold 7 times however much the student tickets cost, which is why. I don't know what the price of the student tickets was, but I sold 7 of them. Okay, so this would represent the money that I collected from the adults. This would represent the money that I collected from the students. And I know all together on that first day, I collected a total of $100. Okay, I hope that makes sense. And now I'm going to do the exact same thing for the green equation, or the green sentence. So I read, the school took in $120. So now I know all together, from the adults and from the kids together, I got $120. And where did that come from? I sold 6 adult tickets. So 6 times X. X is the price of the adult tickets. I still don't know how much it is, but I sold 6 of those. And then I also sold 9 student tickets. So that would be 9Y. And all together, I brought in $120. Do you see that? Hopefully that makes sense, okay? So I got one equation from the yellow, one equation from the green, popped everything in, okay? So now I have this yellow equation and the green equation, and it's a system, and I just need to solve it. Well, I'm really close to being able to do elimination. If only one of those 6 x's were negative, then I would have a pair of opposites. So I'm just going to sneak in there, and I am going to multiply maybe the bottom one by -1 to make everything cancel out. So now what I'm going to do is I'm going to rewrite the yellow equation. Oop, wish I had more room here, but I don't have much. 6x plus 7y equals 100. And now I'm going to take that green equation and multiply it by -1. So that's now a -6x minus 9y equals -120. And now I'm ready to add those equations together because I have that pair of opposites. So the x's cancel. I have a -2y equals 100, and a -120 is a -20. Divide both sides by that -2. And looks like y is going to be a +10. Okay, remember how to get your other variable. I go back to one of my originals, so either the yellow or the green equation, doesn't matter which one, and I'm going to plug in 10 for y. So I'll just take the yellow one, so 6x plus 7 times 10 equals 100. So that'll be 6x plus 70 equals 100. I'll subtract 70 from both sides. 6x equals 30. Divide by 6. And that means that x is going to equal 5. Okay, awesome. So then you're just going to find somewhere to squeeze in. Remember that x was the price of an adult ticket. So that means the adult tickets were, they're X, and they're $5. Students, 10. Wow, too bad, students. You get the high priced ones. Okay, and you can't, so in the last example where I was just finding 2 numbers, I can just state the 2 numbers. Here, I can't just say, oh, the price of the tickets are 5 and 10, because it matters who's paying which amount, right? It matters if you're buying a student ticket or an adult ticket. So you can't just say, oh, tickets cost $5 and $10. Well, which is which, you know? So just be mindful of that. You want to always specify which one you're talking about. All right, so number 3 is actually the exact same thing. It's just a different scenario. Now, instead of ticket to a play, it's tickets to a spring musical. Okay, and they can ask this question. It's the same question. They're just going to change the scenario. Okay, so maybe you're not selling tickets tomorrow. We're actually going to be looking at buying shrubs. Okay, it's the same thing. They're just disguising it as different scenarios. Okay, because it comes up all the time, right? These systems. So let's go ahead and try number 3. And okay, let's read. Maria's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 7 senior citizen tickets and 9 student tickets for a total of $187. So right away, before I even go any further, I'm going to highlight that sentence in yellow. So there's going to be my first equation. Then I'm going to keep reading. The school took in $148 on the second day by selling 7 senior citizen tickets and 6 student tickets. So there is my second equation. I'll put that in green. Okay, and then the last thing that I need to do, it says find the price of a senior citizen ticket and the price of a student ticket. So there's the 2 things that I need. So I'll say let X equal senior citizen ticket and I'll have Y be the student ticket. Okay, so now just like I did before, I'm going to take the yellow sentence and turn it into an equation, and I'll take the green sentence and turn it into an equation. So let's switch back to yellow. All right, on the first day of ticket sales, the school sold 7 senior citizen tickets. So that's going to be 7 times however much the senior citizen tickets cost, which I don't know yet, but I've labeled it as X. So that's all the money they're going to get from senior citizens. Then they're going to add to that 9 times however much the student tickets cost. And all together, they're going to collect $187. So there in yellow is day 1. That's what they were able to do in day 1. So let's switch to green. Now we're going to figure out the second day. The school took in $148 on the second day by selling, again, 7 senior citizen tickets, so that's going to be 7X, and now 6 student tickets, so that's 6Y, and they only brought in $148. Okay, so now you kind of get to forget about the spring musical for a minute and just look at the math. I can just look at the yellow equation and the green equation, and I want to solve that system. And again, I'm thinking elimination, because if I just take this and multiply it by a -1, those X's will cancel. Okay, so let's see, where can I squeeze this in? Actually, I'm going to do it right down here. We already did number 4. So I'm just going to rewrite the yellow. 7X plus 9Y equals 187. And now I'll take the green and multiply by -1. So that's now -7X minus 6Y equals a -148. Okay, X's cancel. 9Y minus 6Y is 3Y. And then 187 minus 148 is 39, right? Okay, so divide both sides by 3, and it looks like Y is going to be 13. Okay, so now I have a value for Y, so now I'm going to go back to one of the originals, either yellow or green. I'll do yellow again. So 7X plus 9 times, oh, I should have done the green. Oh, I can, it's not that. So let's assume I'm going to do the green. 7X plus 6 times Y is 13 equals 148. I switched just because the numbers are a little bit smaller. So 7X, 6 times 13 is 78. Yeah. Minus 78 from both sides. So I get 7X equals, that's going to be 70. Divide by 7. And I get X is equal to 10. So now I have my 2 values. X, remember, was the senior tickets and Y was the student tickets. So then just give me a sentence wherever you can find a spot or a phrase or whatever you can do. So I'm going to say the senior tickets that didn't, okay. Senior tickets cost X was 10, so they were $10. The students they are Y, so that would be $13. Okay, and there is my answer to that. Whew. Okay, so I hope this makes sense. I do want you to try the rest on the second page. So 5 through I forget how high. I don't think I went that high. 5 through 8 maybe it was. Hold on. Whoop, 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 whoop. Let's erase all this. Oh my goodness gracious! There we go. All right, so what do I have you doing on the second page? Oh, I did go to 10. Oh, that's right, because 6, 7, 9, and 10 are those easier ones that are a little bit more straightforward. Okay, just the sum and difference of the two numbers. So give this a shot. I know word problems are typically tough and scary, but hopefully with the examples, these first 4 that we did out together, style, it's just a different scenario. So we're just selling tickets, or I think we're selling tickets in all of them. Okay, so give it a shot. Reach out if you have any problems, okay?